It must be getting really, really close to 2 hours UTC. It's got to be getting pretty close. I think so. I think so because just instinctually, I uh, I seem to be here. I'm waiting for it. I'm waiting for it. There it is. It is 2 hours UTC, which means it is time for another live stream of Astronomy Daily Live. And that's exactly what this live stream is. We take an hour or so and talk astronomy for a good hour. We can talk about basic stuff. We can talk about intensely confusing stuff that just flies way over the head, and anything in between. No problemo. This is just a circle of friends um, coming together every single day uh, who share a common passion for astronomy and all things to do with that. Get into some science, get into other sciences as well, at least as far as they relate to astronomy. So yeah, this is just a casual, fun, um, hopefully um, educational, entertaining um, live stream every single day. But I'm also going to be extremely skeptical of things, and I'm also going to be extremely open-minded about things. So I think that's a really, really important aspect of science that sometimes is lost in all the data and all the analysis and all the papers and all the excitement of new things that um, are happening in astronomy every single day. There's always something new going on, and that hasn't stopped for thousands of years. So there's no way with my little hour-long live stream every single day that we're going to run out of topics. Um, I'm going to move over to my chat here, which I already started. See if anybody's there. Uncle Bill is in the house. Hope you're feeling better today, Uncle Bill. Uh, but you're listing pricing snapper parts. Snapper parts? Snapper. I don't. I, I I don't know exactly what reference that is. So maybe you can inform me what exactly a snapper part is. Let's see. I'm trying to get this thing loaded on my smartphone over here. I've got the chat up on my Linux machine, and over on this Windows machine, I'm going to go to my Discord channel, my Discord server, I guess you could say, and you can see the link to that down in the description right now. You can also see where you can link to my Twitter. That's Astro and Music. And I think there's also a link to this YouTube page. Snapper. Okay, that is the reference that I needed. Hey there, Brez Dwells. Nice to see you here. We're just getting going. I'm opening up my Discord channel over on my laptop. The Discord channel there, I think, is called Astronomy Daily Live. So yeah, hope everybody's doing good. We'll just spend a few minutes waiting for folks to come in. Bob Dog, how's everything up there? Hope all is well. It's almost spring. We've got it's amazing to think, but what in 18 days is March 21st, which is so called, the first day of spring. Actually, I sort of see it. I see the equinoxes and um, solstices as more of midpoints. So, uh, so I sort of um, consider March 21st the um, the spring um, equinox to be a midpoint. So that's like mid spring, and the summer solstice to be midsummer. Uh, but yeah, those 4 days, um, the um, equinoxes and the solstices, those are my holidays for sure. I definitely celebrate those days. Yeah, pretty much more than anything else. So those are fun days. It's always nice to mark the occasion, uh, watch the sunrise and the sunset on the equinoxes. Here, it just so happens that and I mean it's if the angles were any different, we wouldn't see this. But from my location here, um, to my east uh, is a national forest with mountains, big mountains, and there's some kind of a ranger lookout or something on two different peaks. And at the time of the um, um, equinoxes, uh, I can see a reflection, uh, probably off a window, um, from one of the locations. And on the solstices, both of them, I can see some kind of reflection from um, a different one. It's just it's very strange because the angles have to be, yeah, more or less right. So if I was a couple of miles north or south of here, or even, well, anywhere else, I don't necessarily think that I would see those. But so yeah, it's very cool. It'll we'll probably start seeing this one around like March 15th, March 16th, and then it goes to about March 25th or 26th. Now, last solstice, uh, I did actually video record the entire event. It happens at sunset, so the sun has to be very low down on the ground, uh, right at sunset. And then we see the reflections. And so, it brightens up, brightens, uh, and then dims, and it's gone. And I have a video of that I need to process because I want, being a scientist, I, uh, I want to look at the light curve there, and see what it looks like. And I'll be able to see scintillation and the whole thing too. But yeah, I sort of want to watch the light curve, and that's just plotting the brightness versus time, right? So brightness versus time, and it's going to be some kind of a curve, right? It's going to get brighter and brighter and brighter, and then fainter and fainter and fainter. I don't know what the shape of that curve is going to be, and it's going to be wiggly, right? It's going to go up, and then down, like that because of the scintillation, and also just the noise um, of the camera itself. So yeah, being a scientist, I have to do those kinds of things. And but I haven't processed that data yet, which is also a lot like a scientist. So it takes a while, to process things. Sometimes because you know you forget, you forget about it. I'm playing with a pick. I don't know why. I'm going to put it down so I don't do that. So drinks of choice tonight are sort of the standard ones. I've got the coffee with the thick mug, the thick mug. Cheers. And tonight, although I am going to be up for a little while, it is going to be the hydrogen hydroxide, which is very calming. And actually, at this point, I could probably use some calming because I've had a roller coaster type of a day for sure. What is that symbol that you just typed in there, Bob Dog? I'm not recognizing that symbol. Oh, okay, yeah, yeah, okay. Drinks. Yes. Choose choose your favorite and bring it into the circle, and have a drink with. Cheers. Clinking beer mugs. Yeah, yeah. All right. That's very cool. So hope everything is well with you up there. Yeah, you're still frozen. Yeah, we had snow down here in southeastern Arizona a couple of days ago. We actually had some snow, no accumulation at all. The great thing about snow down here is that it doesn't last, and that is the greatest. It's the greatest thing about snow here is that it just does not last at all. So yeah, I mean it was just a cold storm that blew through. It's the same one that's hitting the East Coast now. So it's just a cold storm, and drop the temperature of the air, uh, and when that happens, water likes to freeze. So that's exactly what happened. Um, the temperature of the ground, though, is warm still. So, snowflakes, they hit the ground and they essentially evaporate. so, so, but that definitely makes me smile because I am not here. I am not at this location for snow, for sure. I like to look at it up in the mountains sometimes when it's up there, and you know, it's pretty to watch for a little while. It's really pretty, blah 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 blah, right? But I want it to go away, go away. I am here for two primary reasons. Southern Arizona, southeastern Arizona, is sort of a big um, um, astronomical location. There is Kitt Peak, there is Mount Hopkins, there is Mount Lemmon, and there's Mount Graham. And also to the east of me is a oh, I don't know what they call it, but there's a bunch of private observatories over there. Uh, um, Maybe about an hour or so east of me. Right along the New Mexican um, border. What's it? It's not. Uh, I forget what they call themselves over there, but it's just a bunch of private guys that have a bunch of money, and they build observatories, and they look through their telescopes, which is extremely awesome. If they're having fun, hey, do it, man, do it. So yeah, some pretty nice um, um, uh, uh, facilities over there for sure. So I think what I wanted to do tonight, unless somebody has a particular topic, questions of any sort, we can talk about telescopes, we can talk about gear, um, um, instrumentation, data reduction, the analysis of data. We can talk about astro-art, get into visual art, music. Uh, can do that. We can talk about specific news items, Q&A for sure. Feel free to ask stuff. I also reserve the right to ask things because you know I guess I've got a little bit of experience, a little bit of knowledge, but I certainly don't claim to be any kind of an expert. Um, that's one of the problems I sort of see um, a lot is that you know on other shows there are um, 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 astronomers who are sort of put on the spot. I think having to be the experts, sort of the high priests, right? When we have questions, they're supposed to have answers, and I don't know if that's exactly fair to put that kind of um, um, pressure on um, people who are just as flawed um, and brilliant as um, um, anybody else. So yeah, I don't know. I think well, there were two things that I wanted to do tonight. I guess one was I wanted to do um, an object of the day. I think I wanted to do another Messier um, object, and then I wanted to. I've um, I've started a new project, which might turn out to be extremely interesting. And I sort of thought, well, hey, why don't I um, um, let you follow along, and maybe you can also offer um, words of wisdom, advice, uh, uh, anything else might be interesting and um, entertaining uh, to see me, go through a project. It actually involves my scope back there. So yeah, yeah. So those were sort of the two things that I wanted to get into. So why don't we do that? Why don't we do object of the day first? So I'm going to share my screen. We go to infinity. And here's my Discord server. Oh, where is it? There it is. Discord server. But what we're going to do first is we're going to go to random.org, random.org, and we're going to have random.org choose our Messier object for tonight. Charles Messier was a 18th century French astronomer, comet hunter, um, and while he was searching for comets, he also um, stumbled across these other things that sort of looked like comets to him. Of course, he was looking for comets, so pretty much everything looked like a comet to him. It was either a comet or a star. But these objects didn't seem to move. He stumbled across them over and over and over again. And after a while, he's like, oh, what's going on here? So, he noted positions and basically said, these things really aren't worth um, um, looking at because they don't seem to be comets. So, just don't bother, right? Well, these turn out to be 110 um, non stellar objects that can either be galaxies or globular clusters, or um, um, open clusters, planetary nebulae, or gaseous nebulae. And there's 110 of them in the entire sky. And actually, at the spring equinox, uh, is an opportunity to actually see all but one or two of these in a single night, and it's called the Messier Marathon. And if you haven't done that yet, that is something to definitely do at least once or twice, because it's extremely exciting, very very fun, and it's sort of a rush, and you will be absolutely exhausted um, at the end of it, because you're up all night long. You have to start actually still in twilight. The first object that you have to go for is M74, and it's a very 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 faint galaxy, spiral galaxy, and it is really, really, really hard to see because it's very, very faint, and you're looking for it in twilight. So it's just it's uh, yeah, it's really, really hard. It's really hard. So you basically just sort of wait until it's as dark as you can possibly get with it still being up, but it's so low um, down, near on the horizon, that it it's just, that's a challenge. Once you get that one out of the way, it's pretty easy going, so-called um, easygoing, um, until the end of the night. And I don't remember what the last one is, but none of them are as challenging as that one. You have to know what you're doing when you're looking for galaxies in Virgo, because they're all in a cluster, and there are literally hundreds of them in there that aren't Messier objects. So you have to be able to identify which one is which. So yeah, it's a challenge, but it's a lot of fun too. So random.org is going to choose our Messier object for tonight. So we're going to generate uh, a number between 1 and 110. Drum roll, please. Ooh, M29. M29. What I like to do is I like to try to remember if I know this one or not. M29. Arr, arr. Oh, I don't think I remember that one. I don't think I do. Don't think I do. So let's just go to Simbad, which is an astronomical database hosted over in France, and it's just one I've used for uh, 20 plus years. So one's about as good as another. So just because I use this one doesn't mean that you have to at all. If you have a favorite one, let me know what it is, and I will check it out. But for now, we're just going to go to Simbad. So M29, Simbad search. It's an open cluster. Aha. Okay. An open cluster. Let's see. So here are um, the equatorial um, coordinates of this cluster. The first three numbers are the right ascension, and the last three numbers are declination. So that's sort of your longitude and your latitude, but it's just a position in the sky. It's sort of a standard um, um, coordinate system that astronomers use. And yeah, it's just a position in the sky. So let's see. It looks like, I'm not quite sure how. Oh, okay, that's that. So it looks like this cluster is moving towards us at a velocity of like 21.05 kilometers per second. It's pretty bright. We can see to about sixth magnitude if the sky is really, really dark and our eyes are, really, really functioning well. So anything fainter than that, we really can't see with our own eyes. So 6.6, 7.3 is definitely fainter than sixth. When it comes to brightnesses of objects, the astronomers decided that the larger the magnitude, the fainter the actual object. So a visual magnitude of 6.6, right, uh, is fainter than a magnitude of 6. Now, not by much, but it definitely makes it not visible for sure. So we'll come back to the picture here pretty soon. Let's see. So this Messier object also has a bunch of other names. Most of them usually do. They usually have an NGC number, which this one does, 6913. So you can call this object either that by its NGC number or its Messier number. Lots of references. These are, just scientific papers that pro- probably, hopefully, in some way, refer to this object. So in the past 20 years, at least Simbad has, um, has identified 93 papers that talk about this object. So let's see how far away it is. Display all measurements. We can look at its distance from us. It looks like it's 1,148 parsecs away. That's not incredibly far, actually. Let's see. Pull out the handy dandy calculator. 1148, and 1 parsec is 3.26 light years. So, whoop, I added instead of multiplied, times 3.26. So we get 3,742 light years away. So if you were to go out and look at this object tonight, the light that would be hitting your eyes started out from that cluster almost 3,800 years ago. So that's pretty amazing. Cheers to that. So that's pretty far. I don't remember how far, um, like the Orion nebula is, but I want to say it's like 1,500 light years away. So that's, if that's true, which I don't quote me on that, but that's very very close, right? This cluster would be, like 3 times further away. So that's pretty cool. Screenshots. Yeah, cool. Thanks, Uncle Bill. I want to see. I want to see. I'm not seeing anything yet. Oh, it's here. There we go. Yeah, M29. Yoo-hoo! Where is it in the sky? It's over by Cygnus? No. Really? I guess so. Yeah, okay. Well, then it's coming up in the morning for sure. Oh yeah, I'm looking at the time here, 4:53. Yes, yeah. So it'll be up in the morning for sure. I think M29 is a pretty sparse open cluster, if I remember right. Pretty sparse, not a lot of stars. Not a lot of stars there at all. Yeah, cool. Thank, thanks for the pictures, Uncle Bill. That's very very awesome. Very very awesome. So let's go back and well, let's go into Ned. See what Ned has to say about M29, if anything, and then we can look at the um, some of the references too. So yeah, this doesn't have a lot of extra names, although Sinbad seemed to think it did. So again, these are the three coordinate systems that are used by astronomers to um, to, to identify the um, um, positions of objects in the sky. The equatorial system, the um, ecliptic system, and the galactic. So those are three different um, coordinate systems that are used um, to identify positions of things in the sky. I think I just said that. Let's see. Don't really see anything interesting here. Galactic extinction has to do with sort of the amount of stuff between us and an object. I should get into that at some point. Basic information for Messier 29. Let's see, anything else? I really don't see much of anything else here. Let's look at some pictures. Always like to look at pictures. Uh-oh, I got rid of it all. No worries, we can get it back. It's called the cooling tower? Huh. It must be, just sort of what it looks like. A lot of um, open clusters are like that. They present themselves looking like a particular thing, and it's called that, and the name always sticks. So it's called the cooling tower. Let's see if there's anything interesting about the so-called cooling tower. As you can see, this is a very, very, very sparse open cluster. Just a few stars, barely, barely anything at all. I'm remembering this one now. This one, as you can see, has like 4 or 5 bright stars in it, and that's it. That's it. Looks like maybe there's a few lingering ones. Let's zoom in here a little bit. Yeah, see, there might be maybe a few others sort of associated with this, but basically, when it gets down to it, you're looking at 4 or 5 or 6 stars, and that's it. That's it. So, yeah, Messier, when he saw this with his, 18th um, century telescope, he saw a fuzz. He saw a fuzz, but wow, that's pretty imaginative if you can see a fuzz out of that. So yeah, sometimes I wonder a little bit, what was he thinking? What was he really thinking? But yeah, there it is, M29, constellation of Cygnus. You can definitely see that up in the morning. Let's see. I don't know if that's Deneb or not. I kind of doubt it. Kind of doubt it. Yeah, the field of view here is just, it's probably gonna get busier and busier as time goes by. Yeah, there it is, actually. But yeah, not incredibly exciting. Always, some pretty shots though. But M29 is uh, probably one of the most unexciting clusters I've ever seen, and yeah, it's pretty easy to miss it too, which I guess makes it a little bit of a challenge, right? But yeah, it's only a few bright stars, so it's pretty easy to miss. Pretty nice though, gotta say. Got to say. So let's see if there's anything else interesting about this cluster. We can go into the references and see if it talks about anything in particular. Variability survey of the brightest stars, galactic open cluster pairs, groups, and complexes. Yeah, I'd almost call that a complex, not exactly a cluster. H-band spectroscopy. So this is just um, looking at how these objects are moving. So that's pretty cool. Uh, Cygnus OB1 association. OB stars are just very, very, very large, very, very bright, very young, massive stars, and they're usually very blue, and they usually don't last very long. Maybe a million years or so, and then supposedly they explode. Haven't seen one yet though, so I don't know about that. Peculiarities of um, element abundances in galactic open clusters. Huh. O-type population, interstellar extinction in the direction of open cluster M29. Hey, let's look at that one, because that's very specific. So extinction again is just like how much stuff is between us and the object we're looking at, and the basic effect that has is that everything behind it gets a little fainter, but it can also change, the color too. It can change uh, what wavelengths of light get through and what wavelengths of light don't. And so in this case, they've looked. Uh, it looks like they've looked through all this stuff in the direction of M29, specifically M29. So that's pretty cool. The study is based on photometric classification of 1,110 stars down to a visual magnitude of 19. Wow. 7 color system. Same area of extinction is investigated using 1,147 red clump giants. Now, I've never heard of a red clump giant before. I'm going to one. Identified by combining selected 2 color diagrams of the um, two-mass and Spitzer surveys. Um, yeah, and those are just surveys seeing what's what, right? They have particular um, um, instrumentation and certain filters, and they just go and look, and they collect data, and that's what a survey is. It's sort of like a flyby, right? It's just like, okay, what's here? Uh, we can worry about the details of what's here later. Let's just go look. So surveys are extremely neat and extremely important to just sort of get an idea as to what is there, right? It's sort of like recon. Let's see. The investigated area is divided into three parts. Um, uh, steep, steep rise of extinction is observed at a distance of 800 parsecs. So there's not a lot of stuff, and then all of a sudden there is. Should be related to dust clouds and the great Cygnus rift obscuring the stars behind it by 4 to 4.7 magnitudes. That's significant. Each magnitude is 2.5 times fainter or brighter than the previous one. So if there's a difference of 4 magnitudes, that's actually a factor of 10 in brightness. That's an, you know um, one order of magnitude um, fainter. So that's a pretty thick cloud. Let's see, 1.5. Uh, so they identify a cloud, TGU 466. Uh, these values, they correspond to 10 to 12 magnitudes. Wow. Yeah, so that's like 250 times fainter. Uh, that's pretty awesome. Pretty awesome. So then we can go to ADS, the Astrophysics Data System, and take a look at that actual paper. It's very cool to be able to do this and see the actual paper instead of just sort of an outline. You get the actual words from the horse's mouths, as they say. Interstellar extinction in the direction of open cluster M29. So let's see. Let's scan down here and see if there's anything interesting. Extinction based on Vilnius photometry. Vilnius photometry? I've never heard of Vilnius photometry before. I'm gonna have to look into that too. Man, that's the amazing thing about these papers is that uh, you can learn so much. There's so many new things. I'm not going to claim to know what all these are doing, but this, of course, is a diagram. So now you can see M29 here. It's that little concentration of stars, right? There it is. But in all these other areas, so they sort of divided this up into uh, three chunks, and it sort of looks like, chunk A is where there's maybe a lot of stuff, a lot of gas and dust. Chunk B is where there's sort of a moderate amount, maybe, and chunk C is where there's not very much at all. It's not exactly a void, but it's just where there may not be as much dust. As you can notice, uh, the image here is reversed, right? So all the stars are black, and the background sky is white or gray. So you sort of have to invert this in your head and see that, oh, okay, there's a bunch of bright dust here and here, maybe here, right? And then there's not as much bright dust in these areas marked C. So, and they're just showing, sort of a measurement of how much dimming um, supposedly is taking place. It's a pretty good guess. They have to look at the type of star and how sort of intrinsically bright it is, and then they have to make a guess as to um, how far away it is, And with those two pieces of information, they can sort of get a sense of how much dust is out there. And they call it extinction because it's actually how much fainter the stars appear than what they probably should be. Always nice to look at really cool plots like this. Why is that not scrolling down? Come on, dumb thing. So these are just what are called color diagrams. I'm not going to get into that much here. Um, Probably will at some point, but that's one of the cool things about having a daily show is that I don't have to explain everything all at the same time. We can sort of ease into stuff. So let's see if there's anything else interesting here. There's some arrows, looks like pointing to different distances. That's kind of neat. This is a cool paper. And to identify RCGs at large distances, we've applied another method based on 2-mass and Spitzer photometry. So, yeah, they're trying to try different techniques and tricks, figure out what's going on with these things. Some nice data though here. I don't know why my laptop is being so jumpy, but yeah, and we astronomers we like our mathematics too, so we got to throw all that in as well. Got to do it. Nice diagrams though. Yeah, I'd like to get into this a little bit more. The structure of most papers are usually always the same. It sort of follows the scientific method, right? There's an introduction where sort of the problem is laid out, and this is what we've seen in the past. This is sort of the problem that we want to solve, and then they get into okay, this is how data was collected, um, um, different um, um, instrumentation, all of that, and then they get into okay, now we have all of this data. What do we do with it? We run it through different tools to make sure that the data is calibrated, um, make sure that it's all looks okay. There isn't anything weird or strange. You've gotten rid of all the systematic problems, all of that. Um, and then you can get into a discussion of, what do you think is going on? Here's all the observations. Here's all the data. What do we think is this all about? And so there's usually a discussion of some sort where results are presented, and then they have conclusions. It's like okay, based on what we thought and based on what we've observed, what data we have, what conclusions, what um, results we've seen. These are the conclusions. So they measured the extinction, the stars becoming fainter because there's this stuff in between us and them. So they measured that, a bunch of different stars. Let's see. Distance of the dust clouds in the rift in the direction of M29 is found to be 800 parsecs. So the cluster itself is, I think, according to Simbad, right? We said it was like 1100 and something, but there's a dust cloud at 800 parsecs. So that is definitely between them and us, for sure. Let's see. This means that these clouds. Okay, yeah. At the northern edge of the rift. regions A, B, and C, different values of obscuration. Yeah. A, yeah, very cool. Very cool. But yeah, there's a little bit about M29. That's probably one of the most uninteresting Messier objects there are. The only one that is less interesting than that. Hey there, Warnock 69 XXX. Glad you could come in for a little while. The only Messier object that is less interesting than M29 is M72. Now, M72, there's a controversy, right? Because there doesn't really seem to be anything there. Doesn't seem to be anything there. So there's a maybe like a little triangle of stars, but oh man, what did Charles Messier see? Nobody knows. Nobody knows because really there really isn't anything there now. I mean, as I said, there's sort of this triangle of little stars. Um, should we look at that really quick, just for fun? Let's do it. Let's do it. Um, let's go all the way back here. Just because I'm 72. Oh, it's not M72. What is it? Oh no. Is it M70? I don't think it's M70 either. No. Oh, now no, it's M73. There's only 110 of them, so eventually I'm gonna figure it out. Damn it. Let's see, M73. Yeah, okay, M73. It's called a cluster of stars. Let me tell you though, there's nothing there. You tell me if you see a cluster of stars. Do you see a cluster of stars anywhere? Look at that. Now that is supposed to be M73. Oh, come on. So Charles Messier either wrote down the wrong coordinates or somebody made a mistake of some sort because okay, yeah, yeah, maybe that's a little concentration of stars. If you really, really, really use your wildest imagination, yeah, maybe that's a cluster. But it's like, what's the difference between that and that? Nothing. Or that. Okay. So this is M73, but yeah, eh. That's a Messier fail for for sure. He probably, who knows? Who knows? But it has stuck, and so it is a Messier object, quote unquote object, that you need to go and look at in order to, you know, get your certificate saying that you saw that object. So, but it's a joke. That's a real joke. That's really really sad. But there it is. There it is. All right. Well, cool. I'm going to stop sharing, and that probably means I can't slouch anymore. I'm gonna get a swig of this wonderful wonderful liquid. Cheers. And I'm going to invite you all on a journey. I've started a new project that involves that telescope behind us, and uh, uh, this telescope has two capabilities. Um, and it's actually a combination of the telescope and the CCD camera that comes with it. Now, I've got the CCD camera all attached, so I'm not going to take the time to take it all apart, but the project does involve this telescope and that camera. And with those two things, I can do two things. The first thing I can do is a thing called um, 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 uh, photometry, which is the measurement of how bright things are. And the second thing that I can do with this and that camera is something called um, um, astrometry, and that is measuring the positions of things like stars. So that is basically the project at this point is is to get myself set up so I can do those two things with very high accuracy and very high precision, and that is not an easy task. And yesterday, uh, after the show, um, pulled everything out, went outside, started um, the work. This camera has actually two cameras on it. One camera is sort of the science camera. The other camera is what's called a auto guider, and it's a separate CCD chip that allows the the camera and the software that runs that camera to to be able to talk to a telescope and keep the telescope pointed at a certain thing. Um, you can set up a telescope so it tracks pretty well, but all that really fine motion, very small movements. Um, the model really can't deal with. So what you do instead is you have this active camera that you say, okay, uh, that camera sees a particular field of view, certain stars in a field of view, and you say, okay, I want you to make sure that that star right there is always right there. So when it starts to drift out of that, I want you to tell the telescope to move a little bit in order to put it back there. And so while that's happening, at the same time, the the main camera is actually um, um, collecting your data. So it's called auto guiding, and when it works beautifully. What I have to figure out for my system is, well, now a couple of things. I did only have one thing to figure out, but this afternoon I ran into another problem which I'm going to have to solve in some way. So last night, when I plugged everything in, turned everything on, one of the first things that you have to do with the software is you have to connect the the computer to the camera. And in my case, it's done with a parallel port. Yeah, parallel port. Remember those? Parallel port. Um, and when I did that last night, both the main camera and the auto guiding camera um, connected beautifully. I was able to, change the temperature, yeah, I was able, I had full control over both of those cameras. Okay. Uh, but what I have to do, and I still have to do this, is I have to figure out a way to get the software that I have to talk to this telescopes. So I have old camera that needs to talk to a relatively new telescope mount. I don't quite know how I'm going to do that yet. I started trying to figure that out, and I don't I think I know what happened. Um, there was some kind of a driver that got installed that got overwritten uh, with a different driver, and for some reason that new driver isn't, well, I don't know yet, but it's not working right. Um, Last night when I connected all these things up, I had full control over both of the cameras, no problem at all. Uh, I tried to install uh, um, um, this different driver that I thought was going to help me move towards auto guiding, and that just completely messed me up. Completely messed me up. For a while there, I wasn't able to connect to either camera at all. Right now, as of now, I can connect to the main camera, but I cannot talk to the auto guider. And it's just, it's these kinds of things that just drive me insane, right? Just absolutely insane. I'll figure it out. I'll figure it out. But it's just, it's maddening. It's absolutely maddening. So, but the one thing that I do have to figure out that I don't have any leads on at the moment is how the software is going to talk to this scope. So if anybody has any suggestions, any ideas as to where to do that, how to do that, I have no problem. If I have to build things, you know, make cables, if I have to write software, fine. I just need to know. I just need to know, um, um, what I've got to do, right? But now I've got this other weird problem with one of the drivers just wreaking havoc, just wreaking havoc. So the most important thing in this project that I have to be able to do before I can do anything else at all is I have to be able to auto guide. I have to be able to track extremely well. So when I do a long exposure, 5 minute, 10 minute, hour long exposure, um, all the little errors in the tracking, I've got to be able to take those out, right? And so I need the auto guiding in order to do that. It has to be an active thing. The tracking can only do so much, but I need those little movements. And the auto guider does all of that. So now there are other auto guiders that I can buy if I have to, but well, one, there's no budget for this at all, and two, I've got an auto guider with the CCD camera that I have now, and yesterday I was able to talk to it, and today I can't. Arr, frustrating, frustrating. So I'll figure that out, but fundamentally, 100%, what has to happen, what has to happen is that I have to be able to do long exposures. I have to. I have no choice in that at all. Now, what I'm going to do tonight, I'm I'm going to pull it out um, uh, tonight, and what I'm going to do tonight is I'm going to do a series of short exposures, 1 second or less, and Looks like my stream is jumping around a little bit, so sorry about that. Um, but I'm going to do a series of short exposures, 1 second or less, and then I'm going to add them up and see what they look like. So that's another way to sort of get to the same place. Um, not quite not quite the same, but yeah, we'll see how that goes because the tracking is is going to be off. So I'm going to have to um, register the images, and then I'm going to have to stack them. I'm going to have to be able to add them up, and it's just a major pain. I'll figure it out though. So, but that's fundamentally what has to happen before I can do anything else. Before I can, I mean, there's no point in doing any kind of calibration work, photometric stuff, anything, anything until I can work out being able to track uh, with the auto guider working. So, cheers. So, I invite you to join me on this journey. This is essentially day one of this project, and yeah, it. Not going to say much about sort of the end game at this point, but it's very interesting. I think it's going to be extremely interesting. Um, Something that, as far as I know, nobody um, uh, nobody's really doing, and I'm seeing it as an interesting opportunity, to do something not necessarily new, but it's it's an area that is pretty void at the moment. So just like this live stream, I tend to find holes in things, and if I can fill them, I'm pretty compelled to do so. So I found a pretty big hole in terms of the astronomical world, and but what it's going to rely on is to be able to do it, is to be able to to do long exposures, well, short exposures too, but I want to be able to choose my exposure time. I don't want to be limited by exposure times, less than, a couple of seconds, right? I want to be able to do an exposure for an hour, 2 hours, 8 hours, right? If I want to. And the only way that I can do that is with an auto guider. And that's just an active camera that talks to the software running um, on my PC, and then that PC talks to um, the telescope and gives it little um, corrections in tracking in order to keep the object in the same place in the field of view. So that is sort of the current goal. Luckily, uh, we're in a time where the evenings are without any moon, and that is going to be getting more and more and more as the days go by. So I've got a couple weeks of a nice dark sky to work on this, and so I'm hoping that's sort of the short-term goal is by new moon to have an auto guiding system running where I can do as long of an exposure as I want, and then go from there. So 2 weeks, that's a pretty short amount of time, but if it's clear and if I can make some progress, um, get over this silly obstacle that I've sort of fallen into right now in terms of the drivers. It's just the one thing that just pisses me off more than anything else is obstacles. I do not like obstacles. I just want to crush them. So, so you know, if I have to, well, I'm not quite sure what I'm going to have to do. The weird thing about the software that I'm using is that, you know, uh, supposedly I can completely uninstall it and then reinstall it. But when I do that, okay, if it's a clean installation like it was yesterday, okay, yesterday was a virgin installation, first time ever. Okay, there are certain settings that I have to make. I have to manually tell it what kind of camera, what kind of this, what kind of that, all of that. Okay, and you have to do that, right? Well, when I went to uninstall it today, supposedly uninstall it, okay, and then supposedly reinstall it fresh, when I start the software up, all those settings are set. So, obstacles. I hate obstacles. Obstacles drive me insane. It's, as I said, it's all I want to do is crush them. So that's what I'm planning on doing. Um, so hopefully, you know, as I said, you know, the goal, and it's a pretty intense goal, is to get auto guiding and long exposures operational by new moon. So that's just a couple of weeks, less than a couple of weeks now. So yeah, join me on this journey, because the results the results of this project, if I can get myself set up, there's a lot that has to happen in order to um, turn this telescope into a scientific instrument, and that's sort of where um, I'm um, I'm going with this. Now, I've used this telescope and this camera for science before, but that didn't require long exposures. It required actually very, very short exposures. So I wasn't too worried about that, you know, in terms of the tracking and stuff. And in fact, I actually used my other scope, uh, which doesn't track at all. So, and you know, the exposures were short enough. You know, they were of the order of, you know, like a hundredth of a second, right? Because I was looking at really, really bright objects. Um, so no motion um, was seen at all. Got some nice results. Definitely want to show those off at some point as well. But yeah, join me in this interesting journey. As I said, the end game is actually just the beginning, but I need to turn this into a long exposure scientific instrument machine. And so there's a bunch of things that have to happen in order to do that. And yeah, I think probably what I'll do, you know, over the next 2 weeks for sure, is sort of go over all of those points with you. As I said, my goal right now is to remove this obstacle of the drivers and get um, um, auto guiding going. So yeah, if anybody has any suggestions in terms of auto guiding using a piece of software called CCD Soft, um, to run my telescope, which is a Celestron Nexstar 8SE. So that's fundamentally the goal, is to get CCD Soft to talk to this telescope, and you know, tell it, you know, to make, you know, these little corrections in the tracking in order to keep the object of interest in the same place on the camera. So if I can do that in a couple of weeks, I will be a happy camper, because then I can, you know, move on, you know, to calibrate this thing and uh, do all kinds of other cool stuff. And as I said, you know, primarily what I'm I'm going to be able to do is um, photometry and astrometry. So photometry is just measuring the brightnesses of things, and astrometry is measuring the positions of things. And if I can do both of those things, then that, as I said, that uh, makes for uh, an interesting possibility. So I think I will leave it at that right now because it's too early. It's too early to think about all those kinds of things. I need to solve these little problems first, and then I can get to the big problems. All right, it is 3:15 coordinated universal time. I've definitely taken up enough of your time for today. This happens every single day, so I don't sweat that. I don't try to pack a lot in. Hope you had a good time. Hope you enjoyed. If you're new, stumbling across this for the first time, make sure to subscribe, hit the thumbs up, hit the thumbs down. I just like a reaction. Make some comments if you want. I like to see all the comments. I will respond to them, um, and share this video around. I want this channel to grow. I I have found a niche in sort of the astronomical podcast universe, and I I just need to, you know, I think I just need to continue to be persistent. But if there's something that you think that I should be doing or talking about or whatever, help me grow this channel. I think it could be a really interesting thing, and um, uh, yeah. So help me by sharing it around. You know, if you know anybody who has some kind of an interest in astronomy, let them know. You know that I'm here every single day at 2 hours UTC, and I'm here for about an hour, sometimes a little bit more. And it's a circle of friends, you know, who share a common passion for this wonderful science and this wonderful universe that we seem to live in. So, all right, I'm going to get out of here for now. I'm actually going to get out on the sky, take some pictures. Um, Now that I've sort of announced this, I should probably be showing you some pictures as well. So I will tomorrow night. I'll try to get some pictures up on this laptop, so you can sort of see what I'm seeing, and I can definitely over the next couple of weeks I can give you a daily progress report on this new and interesting project that, as I said, I think is it's going to fill a pretty big hole that could be interesting. Could be interesting. So yeah, stay tuned for that. And all right, I'm going to get out of here for now. Thanks for watching. See you in less than 23 hours. One little spin of our axis, a little bit of motion around the sun, a little bit of motion around the galaxy. It's only 20 million kilometers a day. So what's the problem? No problem. We'll see you again tomorrow. All right. Peace and cheers.